Welcome, this is my channel Try to Understand Mathematics. Now I provide chapter wise some question for joint IIT exam. So please like my videos, share in your friends and subscribe my channel to get my video at first. Okay. My topic is continuity and differentiability. Let us take a problem. If the function is continuous at x equal to 0, then what will be value of a? Either 8, either 1 by 8 or minus 8 or 0. First pause my video and try to yourself. We know of a function is continuous at a point x equal to 0 if their left hand limit at x equal to 0 and equal to their right hand limit at x equal to 0 will be equal to f of 0. Then we say that this function fx is continuous at x equal to 0. Let us first find limit extends to limit left hand limit to limit extends to 0 minus f of x. This will be limit extends to 0 minus when x is less than 0, this fx value is this. So this equal to 1 minus cos of 4x by x square. Okay, so this equal to limit x tends to 0 minus this value is 2 sine square 2x as cos 2 theta equal to 1 minus 2 sine square theta. Okay, from here this is so x square, this can be written as 4x square by 4. So limit x tends to 0 minus 2 into 4 sine 2x by 2x whole square. So this will be 8 into limit x tends to 0 minus sine 2x by 2x whole square. X tends to 0, so this can be written 2x tends to 0. So what will be this value? This value is 1. So this equal to 8 into 1, that is 8. Okay. Now calculate right hand limit of f of x at x tends to 0 plus. When x greater 0, that means functional value is this root x by root under 16 plus root x minus 4. Okay, if we put here 0, this will be 0 and this will be 4 minus 4, that is 0 by 0 form. So we apply L'Hospital rule. So this equal to limit x tends to 0 plus this will be half into x to the power minus half, and this will be 16 into half into x whole to the power minus half into derivative of root x, that means half of x to the power minus half. So this is cancel, this is cancel. So is equal to 2 into 16 plus root x whole to the power half. So if we put here x equal to 0, this will be 2. So this equal to 2 into 4, that is 8. So we know f is continuous at x equal to 0. So limit x tends to 0 minus f of x equal to limit x tends to 0 plus f of x, this equal to f of 0. So this is 8, this is 8, and f of 0 when x equal to 0, functional value is a. So this equal to a. So at the value of a is 8. So our option A is correct. Okay. Let us take another problem. Another problem, f of x equal to this function is continuous at x equal to 0, then what will be value of abc? First pause my video and try to yourself. Okay. Here, first we calculate left hand limit. So this will be when x less 0, this is sine of a plus 1x plus sin x by x. So this is sine of a plus 1x by a plus 1x by a plus 1. This can be written as so sin x by x. Okay, we know limit of fx plus gx equal to limit a plus limit gx. Okay, here we apply this result. So this will be a plus 1 into sine of a plus 1 x by a plus 1 into x plus limit x tends to 0 minus sin x by x. Okay, so this value is 1, so this will be a plus 1, this value is 1, so this is a plus 2. Okay, if we calculate right hand limit when x is greater 0, functional value is this. So this equal to limit of x tends to 0 plus x plus bx square whole to the power half minus x to the power half by bx to the power 3 by 2. This equal to limit x tends to 0 plus, if we have x to the power half is common, so from here we easily see that this will be 1 plus bx whole to the power half minus 1, and this will be bx. Okay, x to the half is cancelled denominator from denominator and numerator. So if we put x equal to 0, this is form will be 0 by 0 form. Okay, so here we apply L'Hospital rule. So this will be limit x tends to 0 plus, this is half of 1 plus bx whole to the power minus half into b, this is b. So this equal to b cancel if b not equal to 0. Okay, so this value will be half. Here fx is continuous at x equal to 0, so left hand limit equal to right hand limit equal to functional value. Okay, so left hand limit is a plus 2, right hand limit is half, and functional value f equal to 0 value is when if x equal to 0, this value is c. Okay, so this is c. So from these two we get a equal to half minus 2, that is minus 3 by 2. So value is equal to minus 3 by 2, b not equal to 0, and c equal to half. Okay, so our option b is correct. Let us take another problem. The function fx is 1 by x square minus 3 mod x plus 2 is discontinuous at the points whatever this point, discontinuous. So we know fx is discontinuous at point if denominator, this denominator is 0. So 3 minus this equal to, if this term is 0, then this will be what? Undefined. So this function at this point from this values, or this function will be discontinuous at this point. So this x square can be written at mod x square minus 3 mod x plus 2 equal to 0. So this is mod x square minus 2 mod x minus mod x plus 2 equal to 0. So this, if we take mod x common, so this will be this, and this will be mod x minus 2 equal to 0. So this will be mod x minus 2 into mod x minus 1. So from here mod x will be 1 either 2. That means x will be whatever, plus minus 1 or plus minus 2. So if x is discontinuous at this point. Let us take another problem. Let f function from R to R is defined by fx equal to minimum of x plus 1 and mod x plus 1. Then which of the following is true? Here fx is minimum of x plus 1 and mod x plus 1. First see this carefully. Easily see x plus 1 and mod x plus 1, what will be minimum value? Always x plus 1, as mod x is greater 0 always. Okay, so this is polynomial function of degree 1, so this is always continuous, and also this is also derivative exists at all points, that is differentiable for all values of x. So here option first is fx is differentiable everywhere, that is correct. Fx is not different, this is wrong. Fx greater equal to 0 for all x greater x belongs to 0, this is not possible. If we take x equal to 0, then this will be, sorry, if x is negative, so this value is always less than 1, so this is wrong. If x is not differentiable at x equal to 1, this is also wrong. Here this is polynomial function, so this is differentiable always. Let us take another problem. H is equal to minimum of x and x square for all x belongs to, then which of the following is correct? First pause my video and try to yourself. Here if we write x, minimum of x and x, this can be when x is greater equal to 0. If x greater equal to 1, so if x greater equal to 1, so what will be this value is minimum of x and x square, this value will be x. Minimum always x when x is greater equal to 1, and if x lie between this range, then minimum value is always x square, and if x is less 0, then minimum value is always x. Here we easily see x is, here every value is polynomial function, that means we know from the theorem that every polynomial function is continuous. So here we easily can write hx is continuous for every values of x. Okay, here if we differentiate this function, this will be 1 if x greater 0, 2x if 0 less than x less than 1, and 1 if x less 0. Okay, here if x is greater than 1, that means limit extends to x plus hx will be 1, and when this is less than 1, this value will be 2, so hx is not differentiable. at x equal to 1, as left hand limit is 2 but right hand limit is 1, so this is not equal, so fx is not differentiable. Again, if we see for 0 values, when left hand limit of x tends to 0 minus if hx is 1, and when x is greater 0, then this value will be what? 0. So 1 not equal to 0, so hx is also not differentiable at x equal to 0. So here we see hx is not differentiable at x equal to 0 and x equal to 1. So here hx is not continuous, this is wrong. Hx is differentiable for all x, this is also wrong, as we see that hx is not differentiable at x equal to 0 and 1. H dash x equal to 1 for all x greater 1, this is not equal. When x is lie between 0 to 1, always for all x greater than 1, this value is 1. This value is not always equal. Here fourth coordinate for hx is not differentiable at two values of x. Here we see that x equal to 0 and x equal to 1, this point here fx is not differentiable, so our option D is correct. Okay, thank you.